argument. An argument is the input of the function. So I'm going to say, let's say hello world. This is the string that I'm passing to the print function. So this is my input to the print function. This is my input to print function. And again, I don't want you to confuse this with the input function, because we've also looked at an input function, but this input is in a logical sense, that this function takes an input as a string, and what it does is it performs an action of printing the string onto our console. So it's going to print hello world. So this is the operation, or it is the action that it performs. Again, there is another kind of function that we looked at. It is the input function. So let's say we've looked at something like x equals to int of input. Now I'm doing the typecast here itself, but it's possible that to reduce the complexity of the explanation, I'll just use the input function itself. Input, and I'm going to say, it's possible that you don't give input any arguments, then in that case it's not going to give you any prompt. But since we've studied it using a prompt, let me give a prompt here. Enter a word. The reason I say word is because I'm expecting a string out of it and not necessarily an integer. So what this is going to do is, so we're giving this input function an input saying that enter a word. This is a prompt of the string, and it is going to return us some string object. So if I say that I'm going to give the input as hello from the console, then the x variable is going to store hello in its memory location. So it's going to do something like this. There could be a memory location in our machine's main memory, and it is going to store hello in this x variable. Let's just quickly look at a simple example of that. So let's say, okay, let's functions.py. I'm going to create an entire file here, and let's say x equals to input, and as I said, it's completely up to you if you want to give a prompt here. If you're not going to give you a prompt, if you're not going to give it a prompt, it's not going to print anything on the console. And then we could use another function called print function to print this. Right. So this is a function that generates, and it's going to return you some output. It's going to give you some output, and this is a function that it's going to perform an action of printing whatever is the value that the user has entered. Right. So now it's waiting for us to give the input. So I'm going to say hello world, and I'm going to write this string, and it's going to print it's going to do the action of printing the string that I've just entered. I could do something like a fancy print statement saying x is equals to, do not forget the comma here. I'm going to again do the same thing, hello world, hello world, and it says that x is hello world. So this is how, this is in essence how functions are, how to think about functions. But now let's see how to define functions of our own, because in a lot of cases we'll see, and we also want to know why do we want to deal with functions instead of the code flow that we've been studying so far. So let's say the primary use of a function is to modularize our code, is to modularize. I'm going to keep spelling of tissue. I'm not very good with it. Modularize the code. What this means is, it means that I'm going to separate some repeated functionality. Now, if you look at our previous example, you'll see that this piece of code where we are trying to divide it by 2 and check the remainder, this is common for all of them. This is common for all the cases, and the only thing that differs is this print statement. Although using some more advanced techniques, it's possible to even modularize this print statement itself. But the obvious modularization or obvious compartmentalization of the repeated code is possible here, because this is the same code that we're writing everywhere, and it's sort of redundant to write it every time. It's also, it's not very good to look at. It's not very readable kind of code, which is why this property comes in handy to modularize the code. It also makes our life convenient. Makes it easy for us to develop complex software. Let's say there is some function do something. So I'm just going to give it some input here, and I'm just going to give it some input here, and it's going to do the action, and it's going to return me some result, or it's going to perform some action on my data. It's going to do something, so to speak, and it allows us to build more and more powerful software as you're able to define and implement these functions, and it also makes our code much more readable. So that is the logic behind why we want to work with functions instead of the linear code flow that we've been working with so far. Now we look at how to actually write a function of our own. So how to define a user-defined function. So the syntax for that is something like follows. The syntax is, we'll write the keyword def. So this is a Python defined keyword. This is a Python keyword in Python, and we have no control over this def keyword. And it's also important for us to know that we cannot use these keywords that are defined in Python as variable names. We can use any variable names, but Python does not allow us to use, or it's not legal to use the keywords that are defined in Python as variables. Let's say something like def equals to 0. You can't do this because def is a keyword that is defined internally and reserved for Python use. So its internal usage of Python is going to use that keyword. And this is how we are going to write the syntax. We are going to write the function name. Let's say I'm going to say something like function name, and I'm going to write the open parenthesis, and if any inputs that it is going to take. Let's say it's going to take some input x and y. Let's say these are the inputs that it is going to take. I'm going to close the open parenthesis. I'm going to write the scope, the operator for opening or defining a newer scope, that is colon, and I'm going to write my code for this function name separated by this. There's going to be some level of indentation here, and so you're going to write the definition of whatever is the function name. One of the examples that we want to one of the initial examples that we look at is a simple function of add. We want to give it two numbers x and y, and we want to return what is the sum of the numbers. Let's say I'm going to write another variable called sum, and I'm simply going to use the plus operator again. So a bit about this operator plus. So I'm going to write here. This is it is what is called as a multifunctional operator. It's not. It can be used for arithmetic use. That is to add numbers. It is also used for concatenating strings. concatenating or merging strings, merging two strings. What I mean by that is, let's say I have a string called hello, this is one string, and I have another string world, and if I use a plus operator on these strings, what it is going to give me is a new string which merges these two strings. So this is what it's going to return. It's going to give me one large string which is a combination, which is a merger of the two strings, hello world, and you could use it for numbers and strings. Right. So this is what. So this is how we are going to define our function. And if the only thing that it's possible that you want to return something, if the function you want it to perform something, then it's not necessary that you return anything, but it's completely up to you. It depends on the use case and the context in which the function is required. But since that we are expecting the sum of numbers here, what we are going to do is return, and this is the keyword return that is used. So I'm just going to use, let's say I'll use a red marker over here to separate the Python defined keywords from the user defined keywords. Return, and then what I'm going to return is the sum, and since I've performed the addition operation and stored that addition in this sum variable, I'm going to return the sum variable. Right. So this is how you might want to define a function. Let's take another example. Again, I'm going to use a define keyword def, and let's say I'm going to all I'm going to do is increment. I'm going to pass one variable x to it. I'm not going to forget this colon operator. It's important that you do, otherwise the Python interpreter is going to complain. And what you can do is you can say something like, now if you want to increment it, you could use something like x equals to x plus 1. So whatever is the existing value of x, you're going to substitute here, you're going to add 1 to it, and you're going to store it back to x. And then I'm going to say that to return x, again we'll use the red marker for all the things that are, all the keywords that are reserved by Python, and the white one for either user-defined function or user-defined, we call them as identifiers. So anything, a function name or these parameters, these arguments, the input arguments, or the variables that we usually write in our programs are usually called as identifiers as a whole. Right. And so these are kind of functions that return some value to the user. It's possible that there's a function that does not return anything. Let's say something like, I'm going to write a function def, and I'm going to say do not return, and I'm not going to pass any argument to it, although you could. It's completely up to the use case, and I'm going to simply say something like print. All I'm going to do is I'm going to say this function does not return anything. T-H-I-N-G. Right. And that's it. That's about the definition of the function, and you're not going to use any return statement here. Right. So let's try to do some trivial examples with this. So these were Python defined functions. Now let's try to write our own program defining our own functions. So we'll write a function to add two numbers. We could also write a function to add three numbers. Let's say let's do for three numbers. So we could pass the three arguments. So these are what's called as the arguments or the function parameters. So when you're defining a function, these are called as the parameters to the function. And when you're going to call it, then you're going to say these are different arguments to the function. So I'm going to say something like a sum variable. So now again, sum is a user defined variable. I'm simply going to do an addition operation here, x plus y plus z. Now keep in mind that since it is associative, the addition is associative, so it's possible that we write x plus y plus z. You can write we can add multiple variables in fact. And then we'll return sum. This is what we do. Right. Now what we can do is, it's possible, now this becomes much more elegant. I'll show you how. We'll revisit this example and we'll rewrite this code, and it will do the exact same thing, but it's going to look a much more readable piece of code. And the way that now this definition of function, it's only a definition. It's not going to do anything by itself. You will have to trigger it. You will have to trigger it, or what we call it is, you will have to call it in order to get the output on different parameters. Let's say I'm going to say now it's going to, since it's going to return an integer, it's possible that I can simply use a print statement, and I can use an add function inside of it. I can use it because I know that add is going to return some integer, and it's possible for me to print an integer. So this is going to return an integer. This print is going to simply print that integer. So I'm going to write something like 1, 2, and 3. So these are the variables, or these are the arguments that I'm passing at this call site to the add. Right. And I could write multiple calls to this add. Let's say I could write something like 5, 6, and 7. Right. So it's going to give me two different answers here. It's going to say 6, and it's going to give me what is this going to be? This is going to be 11, and 7, 18. So this is going to give me two different answers, 6 and 18. The reason is because I called it twice. Right. So it's possible for us to call the function multiple times, however many times that we want. And that's really the beauty of function calls, is that you don't have to write that code again and again, that piece of logic again and again. So I could do something like add 1 and 2, and then add 3 and 4, something like this, and I could do increment. So I'm just going to write a short form of increment, but make sure that you write the full function name, or it's going to complain that again. So that's an important piece. Let's say if you want to write something like this add, this is not going to work, and this is going to give us a error. The reason is because we haven't defined this function add, because it's case sensitive. All of this is case sensitive. So capital A double D has not been defined, and you're trying to use it. So this is what it's going to say. It's going to say that name error, name add is not defined, because you haven't defined a function called add. Reverting back to our example, this is what it's going to do, and it's going to work again. Right. So you could have multiple calls to this. Now one nice thing about this is that you could capture the return variable, whatever is the variable that is returned by add, and I'm going to say, let's say 1, 2, and 3, and I'm going to use another variable to store what is returned by 4, 5, and 6. Let's say 6, and then I could operate on these x and y independently. Now that I've got the results to x and y, then I can use them however I want. Let's say if x is greater than y, then I can say that print x higher than y, or else I might want to check if they are exactly equal. Then I'll say that print x equals y. Otherwise, I'm going to say that print x less than y. Right. So the way this program is going to work is so this is just the definition. So this is just the definition, and it's not going to do anything by itself. Only when we are going to call it somewhere in our program, it's going to be of any use. Right. So we're going to call it with some arguments 1, 2, 3. It's going to return the sum of 1, 2, and 3. So that will be 6, and the other function call is going to be 4, 5, 6. And you're going to get the output of 4, 5, and 6 is what is it? 11 and 4, and that's going to be 15. So x is, at this point, x is 6 and y is 15, and it's going to check here. If 4 is greater than 15, it's not. If it is equals to 4 and 15 are equal, no. And it's going to fall back and say that x is less than y, that 4 is less than 15. And this is what it's going to say. It's going to say x is less than y. And this was a lot, I'll admit, for a beginner. But so let's break this down. Let's get a cutout of this program and let's try to understand at a deeper level on our road how this program exactly works. I'm just going to paste it here. Let me paste it. Right. I'm going to increase the font size and we'll take a look how this program exactly works. So as I said, so these are just placeholders. Think of these as arguments or placeholders. These are arguments or placeholders. And when I say that, this is how this is. Def add x, y, z. I'm going to say sum equals to x plus y plus z, and I'm going to return sum. So this is just the definition of the function, and this by itself it's not going to do anything. It's going to be only useful when we call it. So this is how we called it. This is our first call site add 1, 2, and 3. So what is going to happen is, when program reaches at this point, when the Python interpreter reaches at this point, it's going to see that there is a call to the function add, and it is first going to check whether this function add is defined earlier or not. It has been defined, so it's not going to give us any syntax error. And that is the reason why when we said that x equals to capital A double D and given the parameters as 1, 2, 3, it first checks that if this function is defined or not. So we haven't previously defined this function, which is why it's going to complain about the name error, saying that this function has not been defined. But back to our argument, saying that this function is previously defined, so that is correct. And we're passing 3 arguments to this, 1, 2, and 3. What is going to happen is, 1 is going to correspond to x, 2 is going to correspond to y, and 3 is going to correspond to z. So it's going to consider these as placeholders for this call, right? For this call, for this statement of this call, it is going to consider x as 1, y as 2, and z as 3. Then it's going to see that x is 1, it's going to substitute it here, the plus remains as it is, y is 2, and z is 3. So it's going to, okay, now the way it's going to do 1 plus 2 plus 3 is, first it is going to do, since this is associative, since addition is associative and it doesn't really matter which addition you perform first, it's going to perform this addition or it might perform this addition as well. It completely depends on the Python interpreter. But as far as I know, it's going to first perform this one and it's going to go from left to right. So it's going to do this addition first and it's going to generate 5 out of this. Then this plus will be carried as it is, one is going to be carried as it is, and then it is going to do this addition, that is 1 plus 5 is 6. And now once you have this addition, it is going to throw everything away. It has 6, and it is going to assign this 6 to the sum variable. Now there is something important about you need to understand about the sum variable, is that this sum variable is defined in the function scope itself. This sum variable is defined in the function scope itself, and therefore you can only use it in the function scope itself. So, and I'll explain with you in a greater detail right after we understand at a high level how this entire program works, but bear with me for a moment. So the sum variable is going to be alive in the memory only during the execution of this function, and we'll we'll briefly go over how the function execution actually happens, because this is the important piece that a lot of people miss out on, and they fully do not understand how the code is executed underneath on your machine. And it generally makes you a really good engineer. It makes your fundamentals really strong, which is why it increases your capability as an engineer, makes you a really good engineer. So the sum variable is only going to live for the lifetime of this function, and the lifetime of the function is all these set of instruction or these piece of code. Once you return from here, the sum variable will be destroyed from the memory, and it's only going to return whatever is the content at this memory location, that is 6, and it is going to return 6 to the caller at this point. So it's going to return 6 at this point, and so x will be 6, and then you could forget about this call, and you could simply think of something like this, because this add is going to return you 6. It's going to return you 6, and this is the same as x equals to 6, that is assigning 6 to x, right? And the same thing is going to happen with y. This is going to return at 15, so x equals to 6, and y equals to 15. And then you're going to come here at line number 9, and you're going to do the comparison operator, that is 6 is greater than 15. Now this is going to return you false because 6 is not greater than 15, which is why this statement is not going to be executed. So you'll fall back to this at line number 11, and you're going to check, is 6 equals to 15? Is 6 equals to 15? This is also false. This is also false. And this code is not going to be executed again. The elif block is not going to be executed. Then it is finally going to fall back here, and it is simply going to execute it. You don't have to check any condition over here, because it's implicitly understood that if all of these checks have failed, this definitely must pass. This is definitely going to execute, so that it's going to go ahead and print x is less than y. So that is how it printed x is less than y. Now I want to go a little bit deep into the mechanics of how function calls actually work at the machine level. So bear with me, this is going to be a bit more involved than what we've done so far. So let's get started with that. Let's consider a very simple example. I'm going to define a function add. Okay, let me be a bit more careful here. So this def is a Python defined keyword. I'm going to take 2 arguments. There's going to be a colon over here, and we are going to write this sum variable equals to x plus y, that is, I'm going to do the summation of x and y and assign it to the sum, and then I'm going to write a return statement. I'm going to return the sum variable, because that is where I've captured the result of my operation, whatever is the operation that I've been trying to do. And let's say there is a call to our function. Okay, so let's say there is another, variable in our program called result equals to add of x and y. Now I'm going to pass 1 and 2 as the arguments, you could pass anything that you like. So the way this program is going to work internally in our machines is as follows. Okay, help me a bit here. Okay, right, better. Now, so the way this is going to work is, so it's going to start, now the Python interpreter is going to start scanning our program line by line. So first it is going to come here, it's going to scan this, and it says that okay, this seems like a definition to a function, and it's going to say that okay, there is some function that is being defined, and it'll go through the entire function body, and it's going to record whatever is the code that is written for this function body into the memory somewhere. It's going to say that okay, there is some function, think of it like a piece of code, this is add function, and then there are instructions to add, right? And this is in your what's called as a static memory. This is what's called as a static or code memory. So this is where you store the program. This is where you store the program or the code memory, because after all you need memory to store all this program code itself, right? And then there is something called as a stack memory, which is also called as a runtime memory. It's also called as a stack or a runtime memory. Think of stack in very layman terms, like something like a stack of books. If you have a table somewhere and you're going to place a pile of books in such a fashion. So you're going to place one book on top of another. Let's say this is one book number 1, 2, 3. And if you want to place another book, you're going to place here on top of the book number 3. And let's say you want to retrieve the book number 3. What you do is, you will not directly grab the book number 3. What you do is, first you remove the book number 4 aside. That's how you remove the book number 4 aside, and then you pick the book number 3. Now you have the book number 3 at your disposal, and you're going to place the book number 4 back on top of the stack. So all the operations that you're going to do on the stack are on the top of it, right? So you're going to place data on top of it or remove from the top of it. That's how a usual stack works in real life. And the equivalent of that is also in our machine memory. So think of this whole thing as the memory or active memory, which is used for running programs. This is also called as passive memory, which is used to store programs. But now, since that you want to run this program, you need to bring that program back from the passive memory into the active memory. Well, there's a whole lot of theory why you do this, but we are not going to concern ourselves with that for now. So the stack, what it does is, it is a dynamic memory. So it's going to keep changing over the course of the entire program execution. So it is the kind of memory that is requested on demand. So now let's revisit this, how our Python interpreter is going to read this. So it's going to say that okay, you've defined a function, and you've written all the code to it, and you've stored it somewhere in the memory. Now this is the point where it comes. The control of the Python interpreter comes over here. It sees that okay, there's a call to this add function. First of all, it's going to check if you indeed defined a function called add. If you haven't, then it's going to complain saying that okay, there's no function called as add. But since that we have the code for it, and you're passing two arguments 1 and 2 over here. You're passing 1 and 2. So what it is going to do is, in the stack memory, it is going to create something called as an activation record. It's going to create an activation record or a stack frame. It's also called as a stack frame. Or you could call it as activation record. So this piece of memory is going to be alive during the function execution only. So what it is going to do is, it is going to call the add function with the parameters 1 and 2, So x will be 1, y will be 2, and what is going to happen? Okay, now let's look this in much more detail. The stack activation record. So when you're calling a function, when you're triggering a call to function, what you're going to do is the stack is going to create the stack memory. You're going to create an activation record for the call of this function. So this is an activation record for this call site. So it's going to be add, going to be x, y, and since you're passing 1 and 2, so x is going to be 1, y is going to be 2, and it is going to allocate, it is going to create some memory for another function, another variable. Okay. Now it's also going to create memory for these x and y variables. There is some memory location created for x, some memory location created for y, and it's going to create a memory location for sum as well. The sum variable is going to create the memory location sum. It is going to perform the addition. The CPU, okay, so this is how it executes internally. So you will get x and y from these memory locations. You will read from these memory locations, get x and y, and this is what is called as an ALU hardware unit, that is arithmetic logic unit. You must have known from these junior classes. This is what's called as, this is the circuit that actually does the addition operation, and it is going to generate the result. That is 1 plus 2 is going to be 3, and this 3 is going to be routed back to this place, this memory location of sum, and you're going to store 3 over here. And now, so this is what is going to happen. You've done the addition, and now it's time for you to return the sum variable. So when you return the sum variable, you are going to return this variable. You are going to return this variable. So 3 is going to be returned. So this whole thing can be substituted for 3. The whole thing will be substituted for 3. And now you can conveniently forget there was a call over here and treat it like it was an assignment 3. But you should be thinking at the back of your mind, okay, there was a function call which returned an integer 3, and it is going to be stored somewhere in another memory location. Somewhere in another memory location there must be another stack frame which is going to store the result. This result variable, there should be a memory allocated for it. It's going to store 3 inside of it, right? And once we've returned from this point, what it is going to do is now this add, the call to this add is no longer required. So what it is going to do is it is going to erase all this memory. It is going to erase or free all this memory, because memory is ultimately a limited resource, and your memory will be freed after you return this, right? And the same thing will happen on another call to add. Let's say there is another call that I'm doing for add. Let's say this is result 3. Now I'm doing another, I'm saying result 2, res 2. That's short form for result 2. You could name it as anything. And I'm going to pass on, let's say 4 and 7 here. I'm going to do another call for add. Again, the same thing is going to happen. It's going to create an activation record on your stack memory. It's going to create an activation record for the add function. Here's x and y. Then you're going to allocate memory for x. You're going to allocate memory for y. You're going to receive the inputs for x, 4 in x and 7 in y. Again, you're going to create the sum variable. You're going to allocate memory for sum. You're going to do the addition. So let's say this is the ALU. It's going to take x and y as 4 and 7, and it's going to generate 11 over here, and you're going to store this generated result 11 into the memory location of sum, and finally you're going to return this 11 back from this activation record at this place. This is where you're going to return it. And you can conveniently forget about this and say that this is 11. And once this is done, you're also going to be very responsible, and well, you don't have to be explicitly free this memory. The Python interpreter or the Python runtime environment is going to do that for you. So this is how the function calls are executed internally. So they are created. The memory is created to execute that piece of code on demand. So it's not something like you're going to allocate it beforehand, but you're going to create it on demand. And once you're done computing all the result, and once you're completed all the instructions of the function, it is going to wipe out all that memory. And if there is something to be returned, it's going to return. Otherwise, it's simply going to gracefully exit that function call. Right. So that is how function calls work internally, and this is how this entire piece of code is being worked. So I guess I hope this was useful. I hope you learned something. If you have any doubts, you can let me know down in the comment section. But for now, I'll take it. Thanks everyone.